In this lesson, we're going to talk about electromagnetic devices. Our learning target is I can build and explain how an electromagnet works. Our essential questions are, how does a galvanometer work? How does an electric motor work? And how does a loudspeaker work? So, electromagnetic devices. This is any device that changes electrical energy into mechanical energy, so basically movement. A galvanometer, an electric motor, or a loudspeaker. So let's talk about a galvanometer first. So we have a diagram of one right over here. And a galvanometer is a device that uses an electromagnet to measure small amounts of current. So a small electromagnet is attached to a spring. So we have our spring right here. And then we have an electromagnet made of a coil, a current-carrying coil wrapped around an iron core. So we have a solenoid and a ferromagnetic core. Therefore, we have an electromagnet. So the electromagnet is placed between the poles of two permanent magnets. So a north pole right here and a south pole right here. So when there is a current in the electromagnet's coil, it attempts to align with the field of the permanent magnet. So basically, you are creating an electromagnetic field, and that field then will align with the field that's here, that strong field between the two magnets. So the more current that is flowing through the solenoid or the electromagnet, the stronger the magnetic field it creates, and therefore the more it will rotate to align with the field of the two permanent magnets. What this then does is you have a pointer here, and it's attached, and the pointer will move, and whatever your scale is, it will tell you where it aligns on that scale. This is actually used in cars, in gas tanks. A galvanometer is used in order to indicate whether or how much gas is left in a gas tank. So let's talk about an electric motor here. So our definition is a device that uses an electromagnet to turn an axle. So we have a circuit here with a loop of wire that goes around here. And this loop of wire is between two poles of a magnet. So when current flows through this loop of wire, one side of the loop is pushed by the field of the permanent magnet, and the other side is pulled by the permanent magnet. So that should make sense because in the loop, you have a magnetic field that goes around the wire, and on this side it is facing in one direction, on this side it is facing in the opposite direction because the wire has taken a turn, and therefore when you put the current through there, it causes this loop to turn. Now, if that were just a simple circuit, that would be it. It would turn once, and then it would be aligned with the permanent magnet's fields, and it would be done. However, there's a commutator ring. This is two C-shaped pieces of metal. So this commutator ring rotates, and it switches the direction of the current. So if you look here, we have one C-shaped piece of metal, and so the current goes here, and it goes through this wire and all the way around and then comes back. So the current is flowing in this direction. However, when this piece rotates, now all of a sudden, this C-shaped piece of metal is now on this side, and so now this part of the wire over here will change the direction, or will now have the current going this way, but it will be over here, and so it rotates again, and it rotates again. So this causes it to rotate again. As long as current flows, the motor rotates. Finally, a loudspeaker. A loudspeaker is a device that uses electromagnets to convert electrical signals into sound waves. So a solenoid is placed around one pole of a permanent magnet. Now, a current that changes direction and increases or decreases is moved into the speaker. It flows into the speaker. This is our electrical signal. And as that moves through the solenoid, that means that the solenoid coil is going to have a changing magnetic field depending on the direction and the strength of the current flowing through it. So, the magnetic force from the permanent magnet makes this solenoid coil move back and forth. So, you have a permanent magnetic field and you have a changing magnetic field. As the magnetic field of the solenoid changes, it will cause the solenoid to move as it aligns with the permanent magnet's field. As the coil moves, it vibrates a thin membrane, and that thin membrane then produces sound waves and reproduces the sound that the electric signal sent.